Okay, question 7, we've got a nice little complete the square number, and they're trying to help you out here by giving you the form of complete the square, so that's very good of them. So the first thing you want to do is to take out a common factor. Now there's different ways of doing this. This is how I like to do it. I would take out my negative 6 to leave me x squared, take away 4x, and leave the 25 as is. Okay, I don't like taking the common factor of everything, and as you can see from here, you can't take a common factor there, so you get a fraction, and it becomes annoying. So I think the best thing to do, even to get this as an x squared on its own, I would just take out the common factor from these two terms. So I've not changed anything, just taking a common factor, that's good. Now, we half the middle term here, so I've got x, take away 2 squared. So all I've done there is I've just halved this number, divide by 2. Okay. The negative 25 just stays exactly where it is, and this is the fix we need to do now. Takeaway should just live here, that you're always now going to take away the thing that you add in which you don't want. So by rewriting it this way, I have generated a negative 2 squared times by negative 6, which I don't want. So that's why I'm going to take away negative 2 squared multiplied by negative 6. So it's quite complex, it's quite horrible at this point. But you know, it's not that bad. So negative 2 squared is 4. 4 times negative 6 is negative 24. 2 negatives make a positive, so that becomes an add 24. So I'll rewrite my next line. Everything stays exactly the same, but 25 add 24 is going to give me negative 1. And FYI, the turning point for this is simply just 2, negative 1. You change the sign and stays the same. Change the sign, stays the same. Okay, so that's why we do it. That's why we do this. So now, if I wanted to draw this out, which kind of part B is actually almost suggesting I do, I'll just quickly sketch it. So that's kind of saying that I've got, I've got a happy shape. Sorry, I've got a sad shape because I've got a negative in front of here, and the turning point is 2, negative 1. So it's doing something like this, isn't it? Okay. If I know the turning point, I know the shape, I can roughly draw what's going on. But we'll come back to that in a wee second. So common factor out, halving it, and then you're taking away this thing that you generate. You generate a coefficient of negative 2 squared times negative 6, which you want to get rid of. Okay, and that's why we adjust this number at the end. So, hope that's helpful. This one says, given that f of x is equal to that, show that f of x is strictly decreasing for all those values, for all values, all real numbers. Okay, so f of x is this polynomial. Show that it's decreasing. Okay, well, if I've got a polynomial, or indeed any function actually, and I want to understand if it's increasing or decreasing, that's all to do with the gradient. So this question is really asking, show me that there's always going to be a negative gradient for this function. So I mean, what might that actually look like? We could have a function like this. It could have a point of inflection. It might be doing, something like that. That is always decreasing, isn't it? Negative, negative, negative. That's a turning point I've tried to draw there. Negative, 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 negative. So it could be something like that. So what I have to do first of all is differentiate. So f dashed x is equal to, now again, remind yourself what happens when you differentiate. So x squared would become 2x. So I'm multiplying and then taking away 1 from the power. Multiplying and then taking away 1 from the power. Okay, so negative 6x squared plus 24x, take away 15. That's the differential. Okay, and that's, I was going to say that's wrong because I've written the question down wrong. There we go. Oh no, now I'm writing down a really wrong bit of the question. That's negative 25x. So that's negative 25. Nice one. Now the reason I knew it was wrong is because I know the question wants me to say that this is then equal to our function, yeah? So I know that that is exactly the same as what we just did, which is to write it like this. Okay? So that function, we rewrote it in the complete the square form. So I know this is how my function looks. I know it's going to look like that. 2, -1. It's a negative. It's doing something like this. Okay. So if you think on this as x and this is dy by dx, then yeah, absolutely. Every time I pick off a value, it's giving me a negative value of the gradient. Yeah. So if I was to go along to when x is 4 and go down, yeah, I'm getting a negative value. When I go along to when x is -3, yeah, look at that. I'm getting a negative. So you're always going to have a negative gradient. And the way that we'll write this mathematically, though, okay, so just to kind of be proper, because we are mathematicians here, is I'm going to say that. Well, how am I going to write this? I'm going to say, let me think, -6. I know, I'm going to say, let me think, just to word this perfectly. Yeah, I'm going to say that x take away 2 squared. Okay, so this, no matter what you do, that's always going to be greater than or equal to 0. No matter what happens. So the lowest that will be is 0. So it's either going to be 0 or it's going to be positive. So then, if I was to multiply that by a negative number, that, especially if I then take away another negative number, that has to be less than 0. And the way we write for all values of x is we say for all values of x. So I think the point to watch here is that this one is greater than or equal. That could potentially be 0. But now, and if there wasn't a negative there, if that was +6, +2, you'd be saying, well, that has to be greater than 0 for all values of x. Okay. So yeah, I really should just put that up there as well. There we go. So watch out for that. At this point, you could have a 0, so equal to 0. But at this point, you're going to be less than or greater than, depending on the signs. So you've got this bit in your bracket that has to be a positive. This is always going to be positive or 0. And then, depending on what you've got here, in our case, we've got negatives. You're saying, well, that then is always going to be less than 0, because the very smallest this could be would be 0. 0 take away 1 is less than 0. So I'll just do one. I'll show you what that'd be like if it was a positive. I'll just go to the side here, just to give you the same example for a positive one. So if, say, that was 6, x take away 2 squared plus 1, you would then say, well, x take away 2 squared is going to be greater than or equal to 0 for all values of x, which means that if I multiply it by a positive and add a positive, then it's going to be greater than 0 for all values of x. Again, notice the difference in the signs, okay? And that's you proving this graph effectively as well. I'm just going to check that the marking scheme doesn't say that you can do a sketch, which I think is a bit unfair. Oh no, let me see what there. Oh, there's a wee bit here, wait there. Oh yeah, so maybe you want to say this then. Maybe this is a better way of, maybe this is easier. So what you could also say is you could point to the graph and say that the max value is equal to -1, and -1 is less than 0. So therefore, yeah, f dash x is less than 0 for all values of x. So you could talk about it that way as well. Yeah. Oh, sorry, and the very final thing. So therefore, always strictly decreasing, sorry. Always strictly decreasing. So 2 ways you could look at it. This way is probably a little bit simpler, but actually still the same kind of jargon. I was hoping you could just draw that and just put your answer, but they still seem to want a little bit of chat. So up to you how you want to do it. But yeah, watch out for these signs, and that's it. Yeah, nice one.